Okay, let's go to the next one. 17. 17. Right. Read the following passage and answer the questions. Right. So if that's a long passage, see, that's a long passage. That's a long passage. Now don't read the passage from the beginning to the end first. Right. Don't read the passage from the beginning to the end first. Right. Go to the questions first. Go to the questions first. And then you can go through you can skim through the passage. Right. The passage questions are passage right? That is not going to work out that way, because then you will run out of time, right? You will run out of time in that case. So therefore, go to the questions first. Go to the questions and searching for the answers for the questions, skim through the passage, right? Skim through the passage. Then both will happen at the same time. Both will happen at the same time means you are going through the passage while finding an answer. You are going through the passage while finding an answer. Otherwise, you are not just reading out the passage. Then go to the questions and then go through the passage, right? While extracting the answers. First one, name 3 fundamental physics concepts which can be used to explain some aspect of the stability of soil and sand. Okay. 2017. Okay, see. Name 3 fundamental physics concepts. Explain the aspect of, okay. Then, searching for those, go through the passage. See, fundamental physics concepts such as gravity, friction, and surface tension. Right? So that's gravity, friction, and surface tension. Then first one, gravity, friction, and surface tension. Gravity, friction, and surface tension. Right. Then next one is actually A. This is actually A, part A, right? Yeah. This is A. Then B, write down 3 main mineral constituents of soil. Right, write down 3 main mineral constituents of soil. Right, go through the passage again. Right, everything passage again. You have to find them from the passage. Right. Where is it? Soil gradually in sand. Soil is generally a porous medium covers in mix of mineral particles such as, right, maybe clay, silt, and sand. Clay, silt, and sand. Clay, silt, and sand. Right, Nika, may go through කරන්න. Then what හම්බුයි? Clay, silt, and sand. Clay, silt, and sand. Clay, silt, and sand. Clay, silt, and sand. Right. Then next one. Next one. C. See, in a road construction, soil has been removed from a certain section of the slope, altering the natural slope as shown in the figure 3. Right, this is a vulnerable place for landslides. Explain this using the information given in the passage. Okay. So in the passage, you are given about here angle of free force, no? Right? You are given about angle of free force. Right? Increasing the angle of free force, see this line. Increasing the angle of free force can create instability on the slope. Right? Now, in this case, what happens is, see, now it says angle of free force is alpha. Now, for this angle of free force alpha, that is stable. But if angle of free force is increased, that is going to be unstable. If angle of free force is increased, that is going to be unstable. Now, in this cut, see what has happened. Now, about this side, this angle of repose is greater than the angle of repose given there. Right? Then when angle of repose increases, what happens is, right? When angle of repose increases, what happens is, then the instability, right? Instability increases, right? That's the idea. Then what you need to explain? This is vulnerable place for the sites. Explain using, okay. Then write this way. Since angle of repose, now this angle of repose thing is coming from the passage. Since angle of repose is higher than the supposed value, right? Higher than the supposed value, it becomes unstable. And vulnerable for landslides. Vulnerable for landslides. Right? And the main keyword here is this angle of repose. And you have to say that it is higher than the supposed value. Right? Those are the main keywords. Right? Very important. Because they are coming from passage. Passage එක use කරලා explain කරන්න ඕන. That is clearly given to you to use the passage. Right? Clearly instructed to use the passage. Okay, then part D. Addition of water into dry sand dramatically increases the stability of sand. Explain the main reason for this. Right? When water is added, what happens is, that is given in the passage. When water is added, the adhesive forces between soil and water increases, right? The adhesive force between soil and water increases, right? Voids filled with either air or water as shown in figure B, right? Leaning examples are the parameters. Make water gonna තියෙන කොහොමද කියලා බලන්න. Right? Now, from our knowledge, we know adding water means adhesive force increases, but check whether if there's something else given in the passage. Dramatically increase the attraction between grains. It is due to the adhesive forces associated with the water bridges between grains. Answer. Right? Then explain this way. Adhesive force is a keyword now. Adhesive force is a keyword. Right? Then addition of water, explain the main reason for this. Increasing adhesive force between water and grains. Increasing adhesive force between water and grains. Explain the main reason for this. Increasing adhesive force is a keyword, adhesive force between water and grains results in higher stability, right? Results in higher stability or higher stability of sand. Right? So still we are stick to the passage. We were finding those things from the passage. We were finding all the answers from the passage. Right? E. A water bridge between two spherical sand grains is shown in figure 4. Copy the figure 4 to your answer script and draw the resultant reaction forces using arrows on each grain due to surface tension. Right. I have to copy this down. Right. Then this is how the layer, water layer here is. Right. This is how the water layer is. Right. This is how the water layer is. So we know uh, the adhesive forces are acting on the contacting points. No, adhesive forces are acting on the contacting points open to open to atmosphere. Then here we have one adhesive force. Then similarly here again, and here. Right? These are the forces. These are the forces. These are the contact points open to air. These are the contact points open to air. Right? Then you do surface tension. Then F. Consider the water bridge formed by two sand grains shown in figure 1b, where the radii of curvature of the copper and lower menisci are R1 and R2 respectively. Right? Methana diagram में दिया दिब्बन को like this. Right? Figure B like this, lower meniscus and upper meniscus. Then it is like this. B, A, and the height is given as H. Okay. Then 1b, where the radii of curvature of the upper and lower menisci are R1 and R2 respectively, using the expressions for the pressure difference across the upper and lower air water interfaces. Derive an expression for the height h of water column in figure 1b. Take surface tension and density of water as T and D respectively. Assume that the pressures at points A and B shown in the figure are equal. Okay. Pressures at A and B are equal. Pressures at A and B are equal. Then we know pressure difference through a liquid meniscus is given by 2T over R. No? Pressure difference through a liquid meniscus is given by 2T over R. Right. Now let's assume pressure inside this meniscus as P1 and pressure inside this, sorry, outside this as P2, right? Then we know pressure difference through the first meniscus can be written as always inside is greater than outside, right? Then let's assume PA equals PB equals P for our is. Then for the outside I can write, for the pressure difference I can write P minus P1. P minus P1 equals, that is 2D over R1, equation 1, right? From the upper meniscus. Similarly, from the lower meniscus, right? From the lower meniscus, we can write inside this again P, no? Inside this again P. Again P. Then P minus P2 equals 2D over R2, equation 2, right? About P1 and P2. About P1 and P2 we know, right? We can write using hydrostatics P1 plus H rho G, right? Rho is given as D, right? Yeah. Then V1 plus HDG is P2, right? Which means we have P2 minus P1 here as HDG. Then it says P2 minus P1 equals HDG, that is equation 3. That is equation 3. Right now, you will be able to see now, if 1 and 2 are subtracted, we can create P cancels and we can create 1 and 2 are subtracted. P2 minus P1. Then for that, we can plug HDG. Then 1 minus 2. 1 minus 2. Right? 1 minus 2 gives P cancels. 1 minus 2. Then minus P1 plus P2. Then that is directly P2 minus P1. P2 minus P1. Then left hand sides are done, right hand sides 2T over R1 minus 2T over R2. Then 2T over R1 minus 2T over R2. 2D over R1 minus 2D over R2. Then for this we have an answer as HDG. HDG equals 2D is common. Then 1 over R1 plus, sorry, minus 1 over R1 minus 1 over R2. Now what's the answer? What is asked? There are an expression for the height h of water column. Okay, we need H, no? Then subject H. That is done. H is then 2T over dg brackets 2D over dg brackets 1 over R1 minus 1 over R2. 1 over R1 minus 1 over R2. Right? So without writing equations this way, right? There's another method you could do this. There's another method you could do this. You can start from the known point and write pressures up until you reach another known point. Now A and B are known points, no? Then you can start writing pressures at A and you can finish writing pressures at B. Right? That's also fine. Right? මෙහෙම ලියාගෙන ඉන්නත් පුළුවන්. Alternative method. See? Alternative method. Alternative method. Starting from A, that is P, no? Then here you are jumping out. Jumping out means minus 2T over R1. Minus 2T over R1. Going down through the liquid. Then plus H, D, G. And jumping into the meniscus plus 2T over R2. Now we at P again. Hurry, never make lazy. P to P cancels. Then HDG equals අර වගේ equations ගොඩක් simplify කරගෙන ඉන්න දෙයක්වත් නෑ. 2T is common. 1 over R1 minus 1 over R2. Then we need H. H is 2T over dg 1 over R1 minus 1 over R2. Right? Any method is fine. Any method is fine. Next. G. Calculate the height h for situation mentioned in F above. Take R1 equals, okay, values are given. Then h equals, right, 2. T, what about T? 7.2 10 to the power minus 2. 7.2 10 to the power minus 2. Over dg. D 10 to the power 3. 10. Then 1 over R1 is 0.8. Then 0.8 millimeters 10 to the power minus 3. 10 to the power minus 3 minus 1 over R2 1 millimeter 1 times 10 to the power minus 3. Right? Again, simplification. Right? A small simplification. Right, then here 2 times 7.2. That is 14.4, no? 10 to the power 4 කියලා කියන්නේ minus 6 altogether. Right? 10 to the power minus 6 altogether. 10 to the power 3, 10 to the power 4, then minus 6. And here 10 to the power 3 is common, no? Right? 10 to the power 3 is common. That is the 10 to the power 3 at the top. That is common. Then take it out. 10 to the power 3 is common. Take it out. Then inside 1 over 0.8. 1 over 0.8. 1 over 0.8. 1 over 0.8 means we know it is 0.8 is 8 over 10, no? Then 10 over 8. Again 1.25. Ne? That is 1.25 minus 1. 1.25 minus 1. Then 0.25. Then finally, simplify this. Right? 360 comes. Then 3.6 times. 3.6 times 10 to the power minus 3 meters. Right? Which means that is 3.6 millimeters. 3.6 millimeters. 3.6 millimeters. Right? 3.6 millimeters. Next. H. Consider a situation where the pressures at points A and B are higher than the situation shown in the figure 1b. Copy the figure 1b including the two menisci to your answer script and draw the shapes of the two new menisci and clearly label them as X and Y. Okay. Now, what it says is pressures at A and B are higher. Right. Then we have to argue on the change. You have to argue on the change. What's happening here? You have to argue on that change. How to argue on the change? We know delta P is given by 2 DOR for a meniscus. delta P is given by 2 TOR for meniscus, 2 TOR, right? Now we know delta P is pressure inside minus pressure outside the meniscus equals 2 DOR. Now both A and B are pressures inside the meniscus. No? See, both A and B are pressures inside the meniscus. Then when pressure inside meniscus increases, which means when PI increases, see what happens when PI increases, pressure difference increases. When pressure difference increases, now 2T part is a constant part. If it increases, R decreases. Then R decreases. Now the ultimate ultimate impact here is radius is going to decrease. Radius decreases, right? Radius decreases. Now you have to draw this again with a decreased gradient, with a decreased radius, right? You have to draw this again with a decreased radius. Simply මේ වැන් ආගිව් කරලා වැඩේ යන්න ඕනේ. Then this is what is given. Say these are the given meniscus. These are the given menisci, like this, the given ones, and the new ones are with decreased radii. Decreased radii means the curvature becomes, right, more curved, like this. Curvature is more curved. Then X and Y, right, it becomes more curved because radius decreases. So likewise, without arguing, we can't say anything. Without arguing, you can't say anything. Argue kalla මොකද වෙන්නේ කියලා බලන්න ඕනේ. Right. One second. Right. Next. Next. X and Y. Okay. Then part I. Part I. If the pressures at points A and B shown in figure 1b are continuously increasing, what will happen to the radii of the menisci? If the pressures at points A and B shown in figure 1b continuously increasing, right? That is going to continuously increase. Okay. What is happened to the radii of the menisci? Contact angle and the resultant reaction. Okay. Menisci, radii of the menisci, contact angle and resultant reaction. And resultant reaction. Forces due to surface tension forces between the grains. Explain your answer. Okay. Now first thing is you have to check with the radius. No, that is same. Now as I mentioned below before, pressure inside minus pressure outside is 2 TOR. Now if this is continuously increased, like same impact. No, if pressure inside is continuously increasing, then R is continuously decreasing. Then about radii of meniscus, right? Radius of meniscus, then we can say radii of menisci decreases, right? Radius of menisci decreases, right? Radius of menisci decreases. Likewise, you have to argue. Then angle of contact. What about angle of contact? When radius decreases, angle between the liquid and the wall, right? Now when radius decreases, see, when radius decreases, see, this is what is happening. When radius decreases. Then always the angle between, right? Always the angle between the liquid and the tangent drawn to the meniscus, right? This one, see, this is decreasing now. This is decreasing, which means Now angle of contact decreases and the minimum value of angle of contact that it could take is 0. Right? Minimum value of angle of contact that it could take is 0. So it is going to decrease up until 0. Then for this part also we can add it if needed. Radii of meniscus decreases until it's equal to until it is equal to radius of tube. 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 Radii of menisci decreases until it is equal to radius of tube. Okay, then angle of contact also decreases and the minimum value it could take is 0. Yeah, minimum value it could take is 0. Then angle of contact decreases. Angle of contact decreases up to 0. Angle of contact decreases up to 0. Angle of contact decreases up to 0. Right? Then finally, uh, resultant reaction. Resultant reaction. Resultant reaction due to surface tension. Then what happens is resultant reaction is also becoming 0. No resultant reaction. No resultant reaction. Angle of contact decreases, right? And radius decreases. And finally, the resultant reaction decreases to 0. Right? Resultant reaction decreases to 0. It decreases to 0. Resultant reaction also decreases to 0. Right? Then J, last part, J. Write down 2 human activities mentioned in the passage which can increase the likelihood of landslides. Right. Again, that is something from passage. That is something from passage. Right. Passage increase of weight of the soil making ideal situation for landslides. Capillary, yes, and the increase of weight of the soil making the ideal situation for landslide. Damage on the earth's soil surface due to the addition of large amounts of pesticides and fertilizers. Maybe. Then one is addition of large amount of large amounts of pesticides and and fertilizers right. What else? Decrease the surface tension force between the grains and dramatically increase the likelihood of landslides. Okay. What else are given during rainy season? The soil saturated with the water. Okay. Quickly go through the passage and check if there's anything else given, right? That we can match this. See, right? One of the Tagaba. Right. May I create practical problems such as sinking heavy structures on ground. This, of course, due to compression of voids caused by the heavy loads on the ground, leaning of this rubber, right? Another important parameter which determines the stability. Okay. check the human activities. Now the sum is finished. Sum is finished, right? This is something from the passage again. No? Sum is finished. Now here we have adding more water to addition of more water to soil can decrease friction and strength, right? Then addition of more water. Addition of more water, right? Any two. Addition of more water to soil, right? Addition of more water to soil. And improper removal of improper removal of about that it was given in the passage, no? Soil at slopes, soil at slopes, right? And what else? What else? And road constructions, road constructions, road constructions, road constructions in especially in mountainous areas, in mountainous areas, mountainous areas without a proper study, without a proper study, right? So likewise, some facts are given, right? Likewise, some facts are there, right? ඒක නිකන් passage එකෙන් හොයාගන්න. That's it, right? Any questions? Now we have come to the end of the third question also.